this video, I'm going to show you how to calibrate your system in Shōgun Live. One of the first things that you'll notice is that the cameras can now give you some helpful and relevant feedback. As we hover the mouse over this small icon, we can see that the camera is uncalibrated. Whilst you're in camera view, you can double click on a single view to see all cameras together. There's also a button at the top to be able to reset the zoom. As you can see, there's actually quite a lot of noise in our volume. This can be caused by a large number of things such as overhead lights, reflections, or even strobes of the cameras themselves. We'll need to tell the cameras not to use this information because it can introduce noise into the reconstructed data and also cause a bad calibration. We also have two video cameras in our system that we'd like to calibrate. Previously, this would require manually entering a video calibration mode, which would set them up ready to be masked and calibrated. In Shōgun Live, this step now happens automatically. The calibration tab is laid out in such a way to be followed from top to bottom. The first step is to actually mask out all of the noise in the volume that we discussed earlier. As you can see, as the buttons press, the video cameras have automatically entered video calibration mode. We can see that the strobes and the noise have been masked out correctly in the optical camera. However, we noticed that the open curtains were causing some masking problems for the video cameras. Creating a large mask across the sensor is never recommended, and in the case of the optical cameras, it may be correct to actually reposition or re-aim them to avoid this. However, in our case, it made much more sense to just shut the curtains. With the curtains now shut, we used Remask Selected to only mask the video cameras. As you can see, the result was much more acceptable. At the top of the Calibration tab, you can see a drop-down which will allow you to choose your wand. Because our system contains Vantage IR cameras as well as video cameras, we'll be using the Active Wand V2. When using a video camera, it's a good idea to activate video calibration mode and zoom in onto your active wand, just to ensure that the LEDs are circle fitting correctly. With the masking process now complete, we're ready to start the wand wave. A wand wave is a dynamic calibration process which allows the cameras to work out their positions relative to each other inside your volume. It's important to cover as much of the sensor as possible, at various depths as well as various heights. This is going to help provide a much more accurate calibration. Bear in mind that the wand must be able to be seen by the cameras, so keep the LEDs or the markers facing upright at all times. As soon as we start the wand wave process, you'll notice a small table appear at the bottom of the tab. This table will inform you of how many frames each camera's received and how close it is to the specified amount of frames. The default value is 1000, and we find that provides a more than adequate calibration. This can also be represented on the display of Vantage cameras and by lights on the Vero. Flashing blue means that they've begun calibration. If they're quickly flashing blue, they're picking up a lot more frames. And if the camera's turned green, it means that it's received enough frames. Depending on how many cameras you have, your current frame rate, as well as how many frames you've set, this process can take a little time. When performing the wand wave, you might find that your video cameras don't pick up quite as many frames as the optical cameras. This is normal, as the video cameras do not need as many frames to be able to calibrate. After the wand wave has been completed, the video cameras will automatically come back out of video calibration and the calibration process will complete. At this point, it's a good idea to head into the 3D scene and have a quick visual inspection of the calibration. Assuming nothing looks particularly off, we're now ready to set our origin. After the wand wave, the cameras will know where they are in relation to each other, but not the room in which they are in. Setting the origin tells Shōgun the orientation of the room, as well as setting the orientation of the volume. In our example here, we are using ZUp because we're streaming directly into Unreal Engine 4. Following the top to bottom rule, the next step in the calibration process is to set the floor plane. When setting the origin, the floor plane is also set at the same time. However, it's difficult to guarantee that the wand will sit directly flat. This can be adjusted by simply placing a minimum of 4 markers across your volume and clicking Start Set Floor Plane. Under the advanced options, you have the ability to enter in an offset based on the markers put into the volume. For example, we are using 14mm markers with a 7mm base. Therefore, the centroid from the marker itself will actually sit 7mm off the floor. This value can be entered into the offset before clicking Start Set Floor Plane to achieve a more accurate representation of the floor in your volume. This can be visualized by changing the view to an orthogonal side view. You'll be able to see the markers are now sticking directly on the floor. The next step in the process, set floor extents, isn't actually a required step. However, it can be useful to visualize the size of your volume inside of Shōgun. Simply enter the size in millimeters of your volume to change the side of the grid in the software. We know the rough size of our volume, so we're going to enter it now. The final step in the calibration process is to number your cameras. This is an automatic process that works in a ring format. Simply click Auto Number Cameras. With the calibration complete, you're now ready to start calibrating your subject. Thanks for watching. I hope you found this information useful. Be sure to check out the other Shōgun videos.